In this video, we'll quickly go through vectors addition. It will also involve vector subtraction, and we'll be covering those areas which are going to be useful in understanding the fundamentals of physics. Let's get started. Let us first talk about how a vector is represented. Well, a vector is represented by an arrow, and the length of this arrow represents magnitude, and the direction of the arrow represents direction of the vector. And mathematically it is denoted by a vector, it can be b vector, c vector, and so on. If you only want to express its magnitude, then it is written as modulus of a vector, or simply it is written as a, which is the magnitude of the a vector. And now if you only want to express its direction, then the direction of a vector is represented by a cap. What is meant by a cap? Well, a cap is the unit vector in the direction of a vector. What is meant by unit vector? Let's talk about it. Let's imagine that we have a vector whose magnitude is a units. So this is a vector. Now what is the unit vector in the direction of this a vector? Well, a unit vector in the direction of a vector will be a vector having magnitude equal to unity. That means its magnitude is equal to 1, but having the same direction as that of a vector. And therefore, a unit vector in the direction of a vector will be represented by this arrow, which is having same direction as that of a vector, but its magnitude is going to be 1. It is not going to be 1 unit. Remember this. So the magnitude of this a vector is a units. It can be meter per second if we are representing velocity vector, meter per second square if we are representing acceleration vector. So a unit vector is not going to have any unit. Its magnitude is equal to 1, and this is the unit vector in the direction of a vector. So how do we get this? Basically, this a cap, which is the unit vector in the direction of a vector, is equal to a vector divided by its own magnitude. The magnitude of a vector is a units. So if you divide a units by a units, you are going to get 1, and you're not going to get 1 units. So you must remember that a cap is equal to a vector by a, and this a cap is a vector which is a unitless quantity. So we can write it over here that a cap is unitless. And there is one more thing we can note over here, that if you want to express any vector, a vector has two things. One is the magnitude and second is the direction. And therefore from here we can write that any vector, a vector, let's say, it is equal to its magnitude, which is a, multiplied by direction, and direction is a unit vector in the direction of a vector, which is a cap. In this manner we can represent any vector. Let's now talk about properties of vectors. Let's talk about the first property of the vector. Well, a vector does not change by shifting parallel to itself anywhere in the space. That means it does possess the property of a parallel shift. So the first property would be that it possesses the property of a parallel shift. Let's talk about the second property of the vector. Well, if there is a vector and if you rotate it by 360 degree, then the vector does not change. So we can say that it is unaffected by one complete rotation. Let's talk about the third property of the vector. Well, if you have a vector and you change the observer, then the vector is unaffected by the fact that the observer has been changed. That means a vector is unaffected by the change in frame of reference or the change in observer. So we can write it over here that a vector is unaffected by change in observer. And the last property that we will write over here is that the vector is unaffected if you rotate the frame of reference, that is your coordinate axis, x-axis, y-axis. Even if you rotate it, the vector remains unaffected by the fact. And therefore, let's write that the final property of the vector is that it is unaffected by the rotation of frame of reference. So this is all about the properties of the vectors. Let's now talk about what is the concept of angle between the two vectors. Let's imagine that there is one vector which is in this direction and we call it a vector, and there is another vector which is in this direction and we call it b vector, and they are joined tail to tail. So when they are joined tail to tail, then the smaller of the angle between the two is going to be the angle between the two vectors. So here this is going to be the angle between the two vectors, and it is not going to be the angle between the two vectors. Similarly, if let's say we have a situation that one of the vector is like this and another vector is b vector, they are joined head to tail. If this is a situation, then this is not going to be the angle between the two vectors. The angle between the two vectors will be this angle. Basically, the idea is that no matter whatever the orientation of the two vectors is, you have to join them tail to tail. If they are not joined tail to tail, you can move one of the vectors parallel to itself, as we can do that, and join them tail to tail. And once you do that, then the smaller of the two angles is going to be the angle between the two vectors. What if the two vectors are joined head to head? Well, in that case, let's imagine that this is a situation that the two vectors are joined head to head. Then in this case, this is going to be the angle between the two vectors, and this is not going to be the angle between the two vectors. So I hope it is clear what is the angle between the two vectors, as it is going to be required while we add or subtract two vectors. Generally, this angle between the two vectors is denoted by theta. You can also use any other notation for it, but we will be using theta for angle between the two vectors. Let's now talk about the triangle of vector addition. So the triangle of vector addition is useful when we want to add two vectors. Let's see how we are going to do that. Let's imagine that we have this as one of the vector, we call it a vector, and another vector is this vector, which is b vector, and they are joined tail to tail, so that we can identify the angle between them. So the angle between them is theta. So what is triangle of vector addition? In triangle of vector addition, you join the two vectors head to tail and not tail to head. How you are going to do that? Well, you draw first vector, and the second vector is going to start from the point where the first vector has ended. That means from this point we are going to start the second vector. That means the tail of the second vector will be here, and this is how we will draw second vector. So this is first vector, which we call as A. This is second vector, which we call as B. Now what is the resultant? What is the addition of the two vector? Well, the addition of the two vector will be from the tail of the first vector to the head of the second vector, and therefore this is going to be the resultant vector R. So in this diagram, what is the angle between the two vectors? Is it going to be the angle between the two vectors? No, the angle between the two vectors is this angle theta. So what we want to know about the direction of this r vector, and we want to know about the magnitude of this r vector, that means the length of this r vector. So how this r vector is basically represented? This resultant vector is represented as a vector plus b vector. So we are basically interested into two things. One is the magnitude of r vector. When we say magnitude of r vector, basically we are talking about the magnitude of sum of two vectors, and the formula is, it comes out to be equal to under root of a square plus b square plus 2ab cos of theta. So this is the magnitude of r vector. Secondly, now what is the direction of this r vector? Well, the direction of the r vector can be expressed in terms of the angle made by this r vector, either with the first vector, that is a vector, or with the second vector, that is b vector. So let's imagine that the angle made by this r vector with first vector is alpha. This is a standard notation. So what will be this angle alpha? Well, the formula for this will be tan of alpha, whereas this alpha is the angle made by the resultant vector with the first vector, is equal to b sine theta divided by a plus b cos theta. It is basically the magnitude of the second vector sine theta upon magnitude of the first vector plus magnitude of second vector times cos of angle between the two vectors. So in this manner, we must memorize the formulas for the magnitude of the resultant vector, that is magnitude of a vector plus b vector, and the angle made by the resultant with the first vector generally we memorize. Let's now talk about few important results from this expression. So the first important result in this is that if theta is equal to 0 degree, that means this is your first vector and the second vector will start from here. This is your b vector, this is a vector. So this is the case theta equal to 0 degree. In this case, the resultant is going to be maximum and the value of the maximum resultant will be a plus b. Second important result would be if theta is equal to 180 degree. Well, if theta is equal to 180 degree, then let's say this is first vector and second vector is going to start from where the first vector is ending, and we are assuming that second vector is having a smaller magnitude than the first vector. Then in this case, this is a vector, b vector, and the resultant will be this vector r. So what will be the magnitude of resultant vector in this case? The magnitude is going to be minimum, which is equal to a minus b. Now what will happen if the magnitude of first vector is smaller than the magnitude of the second vector? Well, in that case it is going to be b minus a. So we can write that the minimum magnitude of the resultant possible when theta is equal to 180 degree, and that is equal to modulus of a minus b. And as you can see in the previous case, it was the maximum resultant, and the maximum resultant was equal to a plus b when theta is equal to 0 degree. So if the two vectors are parallel to each other, then the resultant is going to be maximum. If they are anti-parallel, then the resultant is going to be minimum. Let's now talk about what will happen if the two vectors are perpendicular or orthogonal to each other. So if the two vectors are orthogonal to each other or they are perpendicular to each other, that means the angle between them is going to be equal to 90 degrees. So if this is your first vector, a vector, and the second vector will start from where the first vector has ended, and this is going to be the resultant vector r. So r is equal to under root of a square plus b square in this particular case. Let's now talk about a special situation wherein the magnitude of the two vectors, they are same. Well, if the magnitudes of the two vectors, they are same, let's say a is equal to b is equal to, let's say it is equal to f. That means this is your first vector whose magnitude is f. This is your another vector whose magnitude is also f. And the angle between them is theta. So what will be the resultant? Well, for resultant, you know that you have to use triangle law of vector addition, and for that the second vector should start from where the first vector has ended. So if this is your first vector, the second vector should start from here. This is your second vector. Both of them, they are having same magnitude. Then the resultant will be from the tail of the first vector to the head of the second vector. So this is the resultant. Well, in this special case, the resultant basically comes out to be equal to 2 times the magnitude of the vectors, which is f times cos of theta by 2. And we must memorize this result as it is going to be used very frequently in physics. So what will be the direction of this r vector? Well, this direction of this r vector will be that it is going to make an angle theta by 2 with either of the two vectors. Therefore, we can say that the resultant is going to be the angle bisector of the two vectors. So we must remember this result, as I earlier said, that it is going to be very frequently used in physics. So whenever we have to write the magnitude of the resultant of two vectors whose magnitudes are same, then we can directly use this result. Let's now talk about subtraction of two vectors. So now we want to subtract two vectors. That means we want to take difference of the two vectors. Let's imagine that this is the first vector a vector and another vector is this vector b vector, and the angle between them is theta, and we want to subtract the two vectors. That is, we want to know what is a vector minus b vector. Well, a vector minus b vector can be written as conveniently a vector plus minus of b vector. What is meant by minus of b vector? Whenever a vector is multiplied by a negative sign, then it reverses its direction, whereas the magnitude remains the same. And therefore, we can say that this difference of two vectors is similar to the addition of the two vectors. That means the first vector will be this vector a vector, and the second vector is minus b vector, which we have to add with this a vector. That means we have to start minus b vector from the point where a vector has ended. It is this point. So minus b vector will be this vector. This is minus of b vector. Obviously its magnitude will be equal to b only, and the resultant here now will be equal to a vector minus b vector. So this is how pictorially we will get the difference of the two vectors, and if we want to get the magnitude of a vector minus b vector, then a vector minus b vector will be equal to a square plus b square minus 2ab cos of angle between the two vectors is theta. So it's not difficult to memorize, because in place of plus we just have to replace it with a negative sign and we will get the magnitude of difference of the two vectors. And what about the angle made by this resultant a vector minus b vector with the first vector? Let's say it is alpha. So this tan alpha will be equal to b sine theta divided by a minus b cos theta. Though this is going to be rarely required, most of the time we will require a vector minus b vector's magnitude, which will be under root of a square plus b square minus 2ab cos theta. And you must note one thing over here, that the angle between a vector and b vector is theta. What is the angle between a vector and minus b vector? The angle between a vector and minus b vector is going to be equal to 180 minus theta. So how to derive this? Well, you just need to replace theta with 180 minus theta in the formula for addition of two vectors. So finally we will get a formula for difference of the two vectors, and here we will get it as minus of 2ab cos theta. That is going to be the only difference. Let's now talk about a few important points in case of subtraction of two vectors. The first point would be, if we have a situation that theta is equal to 0 degree, that means the two vectors are parallel and we want to write about the difference of the two vectors. So let's say this is your a vector and the b vector is parallel to a vector. So if we want to do a vector minus b vector, we have to start minus b vector from the point where a vector has ended, and therefore this is going to be minus of b vector. Why it is in the opposite direction? Because a vector and b vector, they are parallel, so a vector and minus b vector must be anti-parallel. So this a vector minus b vector will be this vector, which is a vector minus b vector. So you can see that when angle is 0 degree, that means if the two vectors are parallel, then in that case the difference of the two vectors is going to be minimum, and that difference minimum is equal to a minus b and its modulus. Let's see another situation. What will happen if the two vectors are anti-parallel? That means theta is equal to 180 degree. If theta is equal to 180 degree, then this is going to be the a vector and b vector is opposite to a vector. So if we want to do a vector minus b vector, then minus b vector will start from where a vector has ended. So this is going to be the minus of b vector. So what is a vector minus b vector? It is going to be this vector, which is a vector minus b vector, and you can clearly see that in this situation the magnitude of difference of two vector is maximum. So we can say that when the two vectors are anti-parallel, that means their angle between them is 180 degree, then the difference of the two vector is going to be maximum, which will be equal to the sum of magnitudes of the two vector, which is equal to a plus b. You can see that this is just reverse. In case of the addition, you can see if theta equal to 0 degree, then the resultant used to be maximum. Here the resultant is minimum when theta is 0 degree, and same goes with theta equal to 180 degree. There, when angle between the two vectors was 180 degree, when the two vectors were anti-parallel, then the summation was minimum. Here the difference is maximum in that case, which is equal to a plus b. Now what will happen if the angle between them is 90 degree? We can talk about it. It's very easy. If theta equal to 90 degree, then a vector minus b vector and its magnitude will be equal to under root of a square plus b square. So it doesn't really matter. If the angle is 90 degree, then the magnitude of sum and the magnitude of difference, they are going to be same. So we can memorize it as a fact that if the magnitude of sum and magnitude of difference, if they comes out to be same, that means the angle between the two vectors is going to be 90 degrees. That means the two vectors are orthogonal. Let's now talk about that special situation when the two vectors are having same magnitude. So we are actually interested into the situation where the magnitude of A vector is equal to magnitude of B vector. Let's say it is equal to V. So we have first vector like this, it is A vector, its magnitude is V, and we have another vector which is this B vector and its magnitude is also equal to V, and the angle between them is theta. So what will be the difference of the two vectors? That means if you want to know what is A vector minus B vector, its magnitude. Well, its magnitude will be equal to 2 times V sine of theta by 2. Basically, when you simplify the entire expression, finally it will come out to be 2V sine theta by 2. And this type of situation we will very frequently see in physics. In physics, at many times you will see a situation that there is a physical quantity that only changes its direction, but it doesn't change its magnitude. Then if we have to talk about what is the change in that vector, then how to do that? So let's imagine that here this is the initial vector, and now that this vector is changing its direction, keeping its magnitude as same, that means let's say it has rotated by an angle theta. So if it has rotated by an angle theta, it has now become a different vector, that is B vector, keeping same magnitude as it was having earlier, and therefore this becomes our final vector. So if we want to find out what is going to be the change in vector, or simply we are interested into the magnitude of change in vector, that is going to be equal to the final vector minus initial vector, and in fact its magnitude is what we are interested into. So in such a situation we can directly write that it is going to be equal to 2 times V sine of theta by 2. So you can recall that in similar case of addition of two vectors, it is going to be 2 times magnitude cos of theta by 2, and in case of difference it is going to be 2 times magnitude sine of theta by 2. So if we memorize these two results, it is going to help us in many places in physics. Now with the help of this concept, let's talk about the situation where you are rotating the vector by a very small amount. So when you rotate the vector by a very small amount, let's try to figure out what will be the change in that vector when it is rotated by a small amount. So let's say we have a vector whose magnitude is V and it is rotated by a small amount. This is going to be the vector after its rotation. Definitely its magnitude is not going to change, so its magnitude will remain as V, and the angle by which we have rotated it is very small, so I'm going to refer to it as d theta. So you can see that this is going to be the initial vector and this is going to be the final vector, and we are interested into finding what is the change in vector. We can refer to the change in vector as dv vector. And we're not just interested into the change in vector, we are actually interested into the magnitude of the change in the vector. So it is going to be represented by this. dv vector is the change, little change in vector, and we are taking its modulus, which is going to be equal to, you can see that this is our special case where the magnitude of the two vectors, they are same, and we want to take their difference, that means the final vector minus initial vector. So its modulus is going to be 2 times magnitude sine of angle between the two vectors by 2, which is d theta by 2. And we already know that since the angles is very small, so sine of theta can be written as equal to theta. So in this case, sine of d theta by 2 will be written as simply equal to d theta by 2, or this is simply equal to v times d theta. So this is going to be the magnitude of little change in any vector if it is rotated by a small amount. Well, this concept is going to be useful in physics in many places where a physical quantity which is vector quantity is rotating. Well, if that vector is rotating and we are interested into knowing what is the time rate at which it is rotating, or that is the rate at which it is rotating with respect to time, then it is very easy for us to do that. All we just need to do in that situation, that dv vector, let's say it is v vector, which is rotating with respect to time. So we want to differentiate this change with respect to time. So this is dv vector by dt. It is going to be equal to v times d theta divided by dt. And what is this d theta divided by dt? It is the rate at which the vector is rotating, and therefore it will then become equal to the magnitude of the vector multiplied by the angular speed with which it is rotating. So we can directly say that the rate at which the physical quantity is changing is nothing but equal to the magnitude of the physical quantity multiplied by the angular speed with which it is rotating. So this is almost all about vector addition. However, there are two things which we need to talk about. One is the parallel law of vector addition, which is alternative to the triangle law of vector addition, and the other one is the polygon law of vector addition, which is used when we have to add more than two vectors. So let's now talk about the parallel law of vector addition. Well, in parallel law of vector addition, you join the two vectors tail to tail. So let's say this is a vector and this is b vector. The two vectors are joined tail to tail and the angle between them is theta. Now you complete the parallelogram in such a manner that the two vectors becomes the two adjacent sides of the parallelogram. So if I try to complete the parallelogram, it is going to be like this. This becomes a parallelogram. Now what is the resultant? The resultant is going to be the diagonal starting from the tail of the two vectors and ending to the other corner of this parallelogram. So this is going to be the resultant, which is again nothing but equal to a square plus b square plus 2ab cos of theta whole under root. So if you can see closely that it is nothing but the triangle law of vector addition. If you shift this b vector parallel to itself in such a manner that b is going to start from the point where a has ended, so it is again going to be your triangle law of vector addition only. But this is an alternative perspective in which we can add two vectors. Let's now talk about the polygon law of vector addition. Now polygon law of vector addition, it is used when we have to add more than two vectors. Let's say we have these three vectors over here, a vector, b vector and c vector. So according to polygon law of vector addition, you try to draw a polygon. That means you take all these vectors in order. What does it mean? That you draw first vector and then you draw second vector. You will start the second vector from where the first vector has ended, and then you draw the third vector. You will start the third vector from where the second vector has ended, and so on. You continue. Now finally the closing side taken in the reverse order is going to be the resultant of all these vectors. For example, if you are interested into writing what is a vector plus b vector plus c vector, so first of all we will draw the first vector. The first vector is this vector, which is a vector. The second vector will start from where the first vector has ended. Therefore this is going to be the second vector, which is b vector, and the third vector will start from where the second vector has ended, and therefore this is going to be the third vector, which is c vector. And now the closing side taken in the reverse order will give you the resultant vector, and therefore this is going to be the resultant. That means r vector is equal to a vector plus b vector plus c vector. So this is how, by using polygon law of vector addition, this is common sense basically, that you are going to get the resultant of more than two vectors. Now the last thing in this section that we will do is the multiplication of a vector with a scalar quantity. So whenever we have a vector quantity and this vector quantity is multiplied by a scalar quantity, then the result is going to be a vector quantity. That means the result is going to have a magnitude as well as direction. So what will be the magnitude of this vector quantity? Well, it is very easy. The magnitude of this vector quantity will be the magnitude of this original vector quantity multiplied by that scalar number. obviously we have to take the mod. And what will be the direction of the vector quantity? Well, if this scalar quantity is positive, then the direction of new vector quantity and the old vector quantity, they will be same. If this scalar quantity is negative, then the direction of this new vector quantity will be opposite to the direction of this old vector quantity. So let's take few example. For example, let's say we have this a vector quantity, let's say its magnitude is 5 units. This is a vector, and if you multiply this vector quantity, let's say by 2, so we are multiplying it by 2, then the resultant is going to be that the direction remains same and the magnitude becomes 10 units, and we denote it by 2 times a vector. Let's take another example, that if we have this vector quantity 5 units, which is our a vector, and if we multiply it by, let's say, minus 1 by 2, so when we multiply it by minus 1 by 2, because of the negative sign, the direction is going to be reversed, and because of half, the magnitude of the vector will become 1 by 2, and therefore the resultant will be in this direction and its magnitude will be 2.5 units, and it will be denoted by minus of a vector by 2. Well, now this is all about vector addition, and if you wish to solve problems specifically related to this topic only and you do not want to waste your time in finding problems in the books or elsewhere, then you can download my application, whose link is provided in the description box below. Thanks for watching.